So we're going to start off by watching a video, and we're going to watch it 2 times, okay? The first time we watch it, I want you just to be thinking of what do you notice, okay? Okay, high five a partner, just someone sitting next to you. All right, with that person, just take 30 seconds each. Share everything you notice. Bring it back together in 5, 4, 3, 2, 1, and 0. Okay, we're gonna watch it again, same video. This time I want to ask, what do you wonder? So think about all the questions. So go ahead and just raise your hand and let me know, what do you wonder about?
So why is he copying?
That's a great question. Why is he doing that?
Why is he doing a copy of a copy?
Why is he doing a copy of a copy?
As I came back, because we brought up, like, is he doing 75% of 75%, et cetera? Couldn't he have just done like 25% of the original one or something like?
That's a great question. Like, is he trying to get to a certain size, and why is he doing it step by step by step? So, someone from this group, what are you wondering about?
What happens if he changes the paper size?
Ooh, yeah, uses like legal size or tabloid size. We're gonna see Dan Meyer do this 9 times. Okay. And so the question I want us to thinking about, I think I hear versions of it and little explorations that you can continue to do from what was surfaced. But I want us to think about, after 9 times, how big or what size will that dollar bill be? You have one resource in front of you, which is just a sheet of paper that pretty much just has the outline of a dollar bill. But is there anything else that you would like to know, or you feel like you want to know to answer that question?
Original dimensions.
What are the original dimensions? This is a standard US dollar bill. Is there a place you can find that? Okay, so if you need that information, find that information. That's cool with me. What were you saying, Mr. Brooks?
You can take out a dollar and measure it.
Take out a dollar measure. We have some rulers if you'd like to measure, do some measuring here. All right, so I'm going to give you some time for you to go ahead and investigate this question. He's going to copy it 9 times. What's the size of that dollar bill going to be?
Right. We can just test it. I mean, if we decrease it, let's just say. So what you're saying is, if we were to say cut the length and width in half, would that cut the area in half?
We're trying to find the final area or the final dimensions or what?
I think you asked a great question about area, so I would say for sure you should explore that.
I mean,
So we're finding the relationship between if we shrink an object, the dimensions will shrink accordingly, but the area.
I'm curious to see what that relationship is between area and dimensions.
Okay.
Could you?
So actually,
Yeah. What's this all about?
I'm just testing it.
every time you shrink it, you multiply them by 0.75, by 75%. For each dimension gets multiplied by 75%. It's the original width or length.
Right?
Yeah.
Why are you doing 0.75 to the 9th power? Why aren't you doing 0.75 times 9?
Because 75% of 75% is multiplied.
So who else could tell me, not you, what is the error? What's going to happen if you were to just multiply it by 9? Actually, I'm gonna come back, but I
75%
want to make sure we're all on the same page about
of
why we're
means
doing that
multiplication.
instead of
If
this.
we were to multiply 15,
So do we have, what's like our, and I think you're moved a little bit beyond that, but catch me up a little bit. Ah,
If you multiply by 9.
okay. That's
we're
something.
trying to shrink it, we're not trying to enlarge it.
And then, so there's something else I'm noticing interesting about this, which is you have a similar structure, but slightly different over here. So what's the reason for having two of these? And multiplying them at that?
So if we're doing this 9 times, then we're doing it 9 times to the length and we're doing it 9 times to the width. And when we find area, this will give us the results of the length shrunk 9 times times the width shrunk 9 times.
So we'll have the final area.
Yeah.
Is that possible? If I give you a ruler, would you mind drawing that
Okay.
on your paper? I'm just curious to see like how big we think that's going to be.
Okay.
Yeah. And let's go ahead and watch a video here that kind of shows this dollar in action. There's a couple pieces of work that we're going to go ahead and look at, and we want to think about what connections we're seeing between the work that you're going to see up here.
So it's the initial length and width of a dollar, and then.
What units did you choose to use, just in case people have different ones?
Inches.
Okay, so these are inches.
Yeah. And then basically the reduction each time up to the 10th copy.
And how were you reducing it each time? What like operations were you
Multiply
doing?
the previous, measurement by 0.75.
Okay, so I'm going to do some annotating here and multiplying by 0.75. Whew, this took a lot of work, right? Did anyone have a more efficient way of kind of getting to our 10th or our 9th copy? What is this all about? Can you explain that to me?
So 15.5 is the length. We didn't even think, I didn't do length and width. That didn't come up. So we just did length, was the centimeters, 15.5 centimeters, the length of a dollar. So we wanted to know 75% of that to the 9th power.
Yeah, why to the 9th power? Why not times 9? You're doing it 9 times.
Well, I was asking for a shortcut.
Uh-huh.
So I was saying, like, do I really need to do all this math 9 times? That's a lot of math. Isn't there a shortcut? Like, could we possibly use exponents? And then my teammates showed me how to maybe do it that way.
And then I heard Mr. Brooks ask this question to his group of, they were really hung up on like, what size? Like, what do we mean by size? Some people were thinking area, some people were just thinking dimensions. And then Mr. Brooks asked a question that I think I really want to focus on. I heard Leo ask it too. If we shrink it by 75%, is the area going to shrink by 75%? And Leo, you have an answer to that question, right? Which is what?
Where it's U10 equals 1.203. I just plug it into the geometric sequence.
Okay.
And when I multiply the actual dimensions by reducing it by 75%, you don't get the same answer.
Does anyone have any thoughts around why you can't just take the area of the first dollar and shrink that by 75% 9 times?
But when we're talking about area, you're legit talking about I shrunk the length by 75%, I shrunk the width by 75%, and then now I'm going to then multiply those two. So it's like you're doing it like double duty.
And I feel like early on you mentioned something about how this idea connects to that. Would you mind saying a little bit about what we're seeing up here?
So on the left, that's the width, I believe. I don't remember which one.
Yeah.
it was.
Yeah.
Let's call it the width, yeah?
And then every time you put it through the copy machine, to you rigid. You multiply it by 0.75, and then I did the same thing on the right. So that means that there's an extra 0.75 that you multiply by each time for the area.
This group came up with this rule pretty early, and I want to pose a question I asked them to the rest of the group for us to think about. What I want to know is, if I give you the dimensions of some shrunken dollar, could you tell me how many times it must have gone through the machine? Okay, so that's